Today on How It's Made. Diamond cutting, wood doors, paintballs, and newspapers. Diamonds are rare crystals composed mostly of carbon. They're the hardest natural substance on Earth. A superb cut manipulates light to maximize the stone's brilliance. That enhances the diamond's beauty and increases its value. Diamonds come in a variety of colors, the most common of which for jewelry is white. They begin as a larger, rough stone. The goal is to cut as big a diamond as possible from it, while cutting away any imperfections that lessen the value. To do this precision work, master diamond cutters use a magnifying glass that enlarges the stone 10 times. They carefully examine and re-examine the rough diamond, trying to determine the best way to divide the stone. They must saw the diamond in the direction of its grain. Then, using hot glue, secure the rough diamond into a holder positioned over the saw. The saw has a very fine bronze blade, but it can't cut through the diamond on its own. Only diamond can cut diamond, so they coat the blade in a mixture of diamond dust and oil. Sawing an average-size rough diamond in two can take up to 4 hours. The second stage of diamond cutting is called polishing. It's the process of forming the diamond. A special machine first tailors the basic shape. Then the diamond cutter puts glue in a mounting tool called a dop. This will hold the diamond firmly in place. He presses the diamond against a spinning cast iron wheel coated with a mixture of diamond dust and oil. First, he removes any marks that were left by the saw. Then, to give the stone its brilliance, he forms facets, a particular pattern of tiny flat sides of various shapes. The facets are designed to reflect light off each other. Each one must be exactly the right size and shape, and cut at precisely the right angle in relation to the other facets to create maximum brilliance. Here he starts with the table facet, which is the flat top of the diamond. How he proceeds depends on the size and condition of the stone. Then come the pavilions, the angled facets that end in a point at the bottom of the diamond. If they're cut too deep or too shallow, light will leak out the bottom, making the diamond dark in the center and dull overall. The ideal slope is approximately 42 degrees. The diamond cutter uses specialized tools to measure the angle. Next, he'll form the crown facets, the ones circling the diamond directly under the table. Using another type of dop, the diamond cutter fashions what's called the girdle, the faceted rim that separates the crown facets around the top half of the diamond and the pavilion facets below. Diamonds are weighed using a measurement called carats. 1 carat weighs 0.2 grams. Polishing a 1 carat diamond can take 3 or 4 hours. When it's done, they boil it in acid to remove any debris. This finished diamond has 58 facets. It's called a brilliant cut. It's by far the most common style of cut, dating back to the 1600s. The quality of the cut is a key factor in grading diamonds. Experts also rate what's called the clarity, the degree of imperfections in the stone. Then there's color. The finest white diamonds are completely colorless, and the rarest colors are the most valuable. Coming soon to a supermarket near you. Food that tells you when it's gone bad. Researchers are developing electronic devices that monitor food freshness and detect potentially fatal bacteria like E. coli. These devices on the packaging would give off a signal when the food inside spoils. We open and close them several times a day in and day out, and seldom give them a second thought. But imagine your home without doors. For one thing, you'd have absolutely no privacy. And what would you slam when you get angry? The first factory makes the doors plywood facing. They start by loading logs into steaming basins for 3 days. This de-ices them in the winter and softens the wood fiber. Inside the factory, the steamed logs line up for the debarker, a machine that removes the bark. The operator projects concentric circles and uses a laser to carefully center the log on the debarker. Positioning is crucial for 2 reasons: so that as little wood as possible comes off with the bark, and to ensure the debarked log ends up perfectly cylindrical. That maximizes the amount of wood veneer a log will yield. The next step is called rotary cutting. As the log spins, a lathe skims off a sheet of wood veneer just 0.6 of a millimeter thick. The average log yields 134 linear meters of veneer. Next, they unroll the veneer and cut it into sheets. Then they stack the sheets by identical grain patterns. Using a laser to position the blade, they cut through the stack to take out visual defects. Then they glue the pieces together. To make veneer sheets for the front of the plywood door facing, the side that will show, they line up the wood's grain and other features in mirror image. For the back, the side that won't show, they assemble the defective parts they cut out earlier. They use 3 veneer sheets to make up the plywood door facing. They apply glue to both sides of one sheet, then sandwich it between 2 other sheets. They feed the 3 sheets through a hot press at more than 100 degrees Celsius. In a minute and a half, the glue cures, and those 3 sheets of veneer become a 3-ply panel of plywood. Then they sand the panel. Plywood door facings can be made from more than 15 different species of wood, from birch and oak to maple and mahogany. At the second factory, they make the core of the door. They glue together strips of wood to form the middle, then frame them with pieces of white pine. A press pushes the core pieces together, then activates the glue not by heat as most presses do, but by microwaves. Next, they sand and calibrate the core. After the glue machine coats the core, they stick a plywood door facing on each side. They stack a few doors at a time into a cold press for a half hour until the glue dries. Then set them aside while the glue cures for another 8 hours. Next, they size the width and length to the final dimension, bevel the edges, and cut the exact height of the door. Then they inspect the door on both sides. A machine prepares the door for hinges. Then another machine cuts the hole for the knob. The finishing process takes just 70 seconds per door. One side is sanded, stained, and sealed, then sanded again and varnished. The machine then flips the door over and does the same thing to the other side. The game of paintball is a cross between tag, hide and seek, and capture the flag. You try to steal the other team's flag and eliminate your opponents with an air gun that shoots an exploding paint capsule called a paintball. Paintballs are made entirely of non-toxic food-grade ingredients. To make the hollow shell, they first pour water into a giant heated mixing bowl. They add a sweetener and a secret combination of food ingredients the company won't divulge. Then, finally, the key ingredient that gives the shell its shape: gelatin, the kind used to make gummy bears. They melt and mix everything for a half an hour. Then line it up for what they call the drop, transferring the gel from the mixer into a heated vat called the gel tote. They filter out any globs that didn't melt. Once the gel is securely in the tote, they lower in a giant blender. They pour in food dye and blend for about 20 minutes. Elsewhere in the factory, they use the same method to dye what's called the fill, the paint that goes inside the shell of the paintball. It's made of polyethylene glycol, the inert liquid in cough syrup. They thicken it with crayon wax. The gel and fill meet their maker in what's known as the feed room. Here, the vats of gel and fill feed a capsulation machine one floor below. This machine is the same kind used to make bath beads and gel cap medicine. First, the machine spreads out the gel onto a cool drum. This creates a continuous thin sheet of gel called a gel ribbon. This cooling cures the gelatin to the point where it can now be molded into the hollow shell of the ball. The machine presses the gel ribbon into a die with half-circle pockets, each forming one half of a ball shell. The machine does the next 3 steps in one shot. It aligns the 2 half shells together to form a hollow ball, injects the fill, then seals the 2 half shells together. These newly minted paintballs are still quite soft, though. If they're not dried out, they'll lose their shape. So they fall down onto a conveyor, then roll into a tumble dryer. From here, they'll go onto a bakery-style rack until they dry out completely. To make dual-colored paintballs, they use the exact same process, but feed 2 colors of gel ribbon into the capsulation machine, 1 color for each half of the shell. The finished paintballs go through an automatic counting machine. This one is set to count out and package 200 balls at a time. Manufacturing this messy ammunition is a painstaking process, but well worth the effort to the millions who love the game of paintball. Invented just 15 years ago, it's caught on in more than 40 countries worldwide. And it's not just for kids. More and more companies are booking paintball outings for their employees. to help build teamwork. There was a time when our only source of news was the newspaper. Today, though, newspapers have to compete with radio, television, and the internet. Still, to get context and analysis of news events, most still turn to the newspaper. In medieval times, people got the news of the kingdom from the town crier and from official notices posted in public places. By the late 1400s, the first printed news pamphlets appeared in Germany. The first English-language newspaper hit the stands in London in 1622. By the 1800s, new printing technology brought the price of newspapers down. This finally made them affordable to the masses, who were becoming more literate. The news editor selects the stories and photographs. They come from the newspaper's own reporters and photographers and from wire services. The news editor accesses the wire services via the internet. Local reporters file their stories to the newsroom computer system. The photo lab scans the photographer's pictures into the system as well. That puts everything at the news editor's fingertips. It's just a matter of moving the various items into the page layout. Once the layout's complete, they group the pages in sets of 4 called flats. The manager checks each flat for errors, paying special attention to the advertisements, the newspaper's main source of revenue. Next, they prepare the printing plates for each page. A plate is a plastic-coated sheet of aluminum, just 0.3 of a millimeter thick. It goes into the cylinder of a machine called the imager. The imager's laser beam scans the plate, hardening the plastic coating wherever the computer tells it there will be text or pictures. The coating in the blank areas that don't harden then washes away in a series of chemical baths. It takes about a minute for a plate to pass through those processing basins. Next, a machine punches registration marks on each side of the plate. The press operators will use those marks as a guide to correctly position the plate on the printing press. After they oil the press's cylinder, they attach the plates. There's 1 plate per page per color, to a maximum of 4 colors. The newsprint comes in jumbo rolls weighing 850 kilos apiece. Workers feed several rolls into the reeling machine under the printing press. 2-sided tape connects one roll to the next, ensuring a continuous, uninterrupted run. This is a 4-color printing process. There's a station for each color of ink. The paper passes through each color one at a time, like a car going through an automatic car wash. The printing starts out slowly, but within a few seconds revs up to 40 kilometers an hour. Press operators adjust the colors as needed. Each line of the press prints a 4-page flat, then it cuts the sheet in half lengthwise, separating 2 and 2. Then it cuts the continuous lengths widthwise into a 2-page spread. Machines automatically assemble the pages in order, then send them off to the shipping department. The stacker makes piles of 50 copies for delivery. Then workers hand stuff the inserts one by one. If you winter jackets, animation, mushrooms, and gold rings. As anyone who's shivered through a Canadian winter knows, you've got your run-of-the-mill winter jackets, and then those really warm winter jackets that can run you up to $1,000. The difference is what they're made of and how they're made. A top-of-the-line winter jacket gives you the warmth without the weight. It's waterproof and comfortable. No bulky stuffing or constrictive styling. The designer draws a pattern by computer. A software program then adapts the pattern to different sizes. A giant printer puts it to paper. The tailor spreads out several layers of each of the fabrics that'll make up the jacket. He lays out the pattern, then pins it in place. Next, he cuts through several layers of fabric at a time with electric scissors. These scissors maneuver much like a jigsaw around the lines and curves of the pattern pieces. The finished jacket will actually be made up of two jackets sewn together, an insulation jacket on the inside and a windbreaker on the outside. The inner insulation jacket begins with a nylon lining. Then they layer the key components, a film to stabilize and protect the insulation, then the thick polyester insulation itself. At this point, the insulation layer is larger than the lining. This ensures that every inch of the jacket will have insulation. Working with one piece at a time, they stitch the layers together. Each line of stitching is tacked at the beginning and at the end for added strength. They cut off the excess insulation, then sew an overlock around each piece to hold the remaining insulation solidly in place. Once they've completed each piece of the insulation jacket, they sew it all together. Next step, the windbreaker. The outer fabric is heavy nylon. The lining is a special fabric with tiny holes large enough to let humidity escape, but small enough to stop water droplets and wind from penetrating. This is what will allow the jacket to breathe, while at the same time making it windproof and waterproof. Finally, it's time to put the two jacket components together. Using two separate strong threads, they sew seams made of knotted stitches. No seams go through the jacket because that would break the insulation barrier and let in cold air. They join the two jackets together only where they have to, at the collar, the cuffs, the hem, and along the zipper. And this isn't just any ordinary zipper. It's made of corrosion-resistant nylon with a nickel-plated slider that lasts 7 times longer than a normal slider. Until now, they've been sewing the jacket turned inside out. Now they turn it right side in for finishing. These heavy-duty snaps have sturdy grips that anchor themselves between the fibers in the material, so they won't tear the fabric with repeated use. Some jackets have decorative embroidery. Designers use a computer program to prepare the pattern. The automatic machine embroiders 5 jackets at once. This intricate owl pattern takes 1¼ hours to complete. The final result is a stylish jacket whose secret weapon is that hidden layer of insulation. It traps air inside. Your body then heats it up, creating a cushion of warmth against the cold of winter. What is biophotonics? Well, bio is short for biology. Photonics is the physics of light. Biophotonics uses sophisticated imaging and other sensitive optical instruments to conduct biomedical research. Biophotonics has a range of uses, from medical diagnosis to drug screening. In the golden years of animated film, teams of animators would draw every single illustration by hand. Today, they do much of their work by computer, but that doesn't mean it's any less artistic. It all starts with a screenplay, a script containing not just dialogue, but also physical descriptions of the characters and background scenery. The art director begins creating the characters. He draws in pencil. When he's finished, he traces the drawing in felt pen. Then he erases the pencil marks. He adds shadowing to create relief. Once he's drawn all the characters, he starts the backgrounds. And then the objects that appear in the backgrounds. The storyboard artist blocks out the film on paper, drawing by drawing. The production team will follow this storyboard the way a dressmaker follows a pattern. They blow up the drawings, scan them into the computer, then play them back in chronological order. This creates what's called an animatic, a two-dimensional version of the film minus the animation. Should the director now decide to change, say, a ground-level view of the street to an aerial view, he has the artist redraw the street from that new angle. Meanwhile, the animators work on bringing the characters to life. Using specialized software, they build a skeleton to fit inside the character's body. When they move the skeleton, the software makes the body move with it. They make the characters three-dimensional using a technique called wireframe animation. First, they build the shape of the character using a wire structure. Then they add color and clothing. They further refine the character by modifying facial features, by adding texture, and by shadowing. They use specialized software to synchronize the character's mouth with the dialogue. The technician works syllable by syllable, picking the mouth movement that matches each sound. It's a painstaking process that takes many months. Another animator applies the lighting effects. Lighting is as important in an animated cartoon as it is in a movie with real people. It creates relief, making everything look more realistic. The animators cut and paste the characters and objects onto the backgrounds. With the characters' movements programmed into the computer, the animators turn the two-dimensional stills version of the film into a three-dimensional animation, essentially a rough cut of the film. Meanwhile, in the studio, the soundtrack takes shape. Actors record the characters' dialogue. The sound technician weaves together the voices, the music, and the sound effects using specially designed software. They sync the soundtrack to the rough cut of the film. Then they refine the rough cut, playing with colors and textures and smoothing out the characters' movements. After a full year's work and more than 42,000 drawings, this 24-minute computer-animated film is finally finished. Have you ever dined on fungus? Well, if you've eaten mushrooms, you have. We like to think of those tasty little umbrella-shaped things as vegetables, but technically, they're fungi. Fungus omelet, anyone? Mushrooms grow in compost, and preparing that compost is a science in itself. It starts with horse manure and straw. The correct balance of moisture and air is critical because mushrooms need both to grow. So mushroom farmers have to turn the pile frequently to air it out, and they water it daily for about a week. This kicks off plenty of chemical and biological activity. Ammonia forms and microorganisms grow and reproduce, releasing heat. Good compost requires a nitrogen content of about 2%, so farmers add a nitrogen supplement, chicken manure. They also add gypsum, a mineral that improves the structure of the compost and neutralizes its acidity. At the week to 2 week mark, depending on how the compost is progressing, it goes into the composter, which waters, aerates, and blends it. The compost comes out chocolate brown, smelling of ammonia. Next, they pasteurize it to kill off any insects or insect eggs. They heat the compost at 58 degrees Celsius for 8 hours, then at 45 degrees for 5 days. Then, over several more days, they gradually cool it to 25 degrees as microorganisms turn the ammonia into a nitrogen protein, a mushroom nutrient. The compost is finally ready. The farmer sows grains of wheat inoculated with mushroom mycelium, fine threads of fungi that act as the mushroom's roots. A layer of soil and peat moss goes on top of the compost. The mycelium draws water from the soil and nutrients from the compost. After about 2 weeks, tiny mushrooms begin to develop. They grow fast, doubling their size every 24 hours. And this in relative darkness. Green plants need sunlight for photosynthesis, but mushrooms don't. What mushrooms do need is air, because they breathe in oxygen and breathe out carbon dioxide. Green plants do the opposite. Another 3 days and the tiny mushrooms are fully grown and ready for harvesting. Pickers have to be careful not to remove the roots, because left intact they'll sprout a new batch of mushrooms every 3 to 5 days for about 3 weeks. They put the harvested mushrooms in a refrigerator just above freezing temperature for about a half hour to stop the growing process. On the packaging line, they weigh the mushrooms and arrange them in a container, buttons up. a machine perforates the plastic covering to let the mushrooms breathe. This ensures a longer shelf life. The mushrooms stay in a fridge until they leave for the store the following day. It's taken about 12 weeks from the start of composting to your supermarket shelf. Gold jewelry has been a symbol of wealth and status throughout the ages. Today, though, it isn't just for the rich. Even ordinary people are likely to have a gold ring or necklace, just a little less diamond-studded. As early as 2000 BC, Egyptian kings and queens adorned themselves in golden jewelry encrusted with precious gems. When the Spanish sailed to the New World in 1492, they discovered Mayan and Aztec masterpieces of colored stones and pure gold. Today, elaborate gold jewelry and precious gems are well beyond the reach of the average person, except for the diamond ring, still the customary symbol of engagement. The client and the jewelry designer first decide how the ring will look. The designer then measures the client's finger to determine her ring size. He then sketches out the design they've agreed upon, a grooved band with 3 diamonds. The model maker works with a special carving wax. Using a compass, he measures off and marks a width of the band, then carefully saws it off. He takes his millimeter gauge and puts it on a stick with ring size markings called a mandrel. He adjusts his compass to the ring size, then scores the finger hole on the block of wax. He then takes his drill and carefully carves out the hole he scored. Then he grinds off the wax on the outside of the band. Using the compass again, he scores the middle of the band where he'll make the groove. Then, using a very fine drill bit, he carves out the groove. With a file, he then refines the groove and shapes the curves of the ring according to the design. After putting wax prongs on the band, he attaches a wax stem to the model. He then positions the stem into the base of the cylinder that the jeweler will use to cast the ring. The base goes onto the platform of a vacuum machine. The jeweler puts a cylinder on top of the base, then pours in a special plaster. The vacuum sucks all the air out of the plaster. This is a key part of the process because if any air bubbles remain, the finished ring will be out of shape. In less than a minute, the vacuuming is done, and the cylinder goes into the furnace at 1,350 degrees Fahrenheit. The wax model evaporates, leaving a void the exact shape of the ring in the hardened plaster. Next, they melt the gold. The gold content of jewelry is measured by carat. The lower the carat, the less gold and the more alloy, cheaper metals such as nickel, silver, and copper. After 5 hours, the cylinder comes out of the furnace and goes into the casting machine. The machine spins for about a minute. The centrifugal force shoots the liquefied gold into the plaster mold that's inside the cylinder. The jeweler then immerses the cylinder in cold water. This cools the gold and makes the plaster disintegrate. What's left is the cast gold ring, but its surface is rough. So, on to the finishing process. The jeweler saws off the stem and gets to work. He files and grinds the ring until the surface is smooth. Then he stamps on his trademark and the carat marking. Then he hammers the ring on the mandrel to make it perfectly round. The jeweler then hands off to a specialist in polishing. The polisher runs the ring against a series of buffing wheels until it's bright and shiny. The polisher then hands off to a specialist in setting gemstones. The setter straightens the prongs that'll hold the diamonds. Then, with a delicate drill bit, he carefully carves out the inside of the prongs. The edges of the diamonds will fit directly into these slots. He readjusts the prongs, then sets the diamonds, making sure the prongs hold them down securely. That's a 1-carat diamond in the middle, a 1/2-carat diamond on each side. The jeweler then immerses the finished ring into the ultrasonic machine. The vibrations in the water penetrate every nook and cranny, washing the ring. Finally, he puts the ring under a jet of hot steam to blast away any remaining residue. And voila! With a ring like that, who wouldn't say I do? If you have any comments about the show, or if you'd like to suggest
Hello everyone, I'm Mark Tewksbury, your host for this program. Our goal is to reveal to you the methods and materials that turn out the products you see around you every day. If you think you know everything about these items, you're in for some surprises. There's a whole new world waiting for us to discover here on how it's made. Today's topics: kayaks, safety boots, cereal, and electronic signs. It's a therapeutic deadly poison. Seems contradictory, but that's the case with certain snake venoms used in homeopathic medicine. Several years ago, they discovered snake venom was an excellent anticoagulant. The cobras, for instance, has analgesic properties and is very useful in treating certain tumors. Who knew? In days gone by, kayaks were used primarily for hunting. Now, modern-day kayaks are marvels of molded plastic available for all sport enthusiasts. A kayak is formed by the melting of plastic on a mold of nickel. This mold is made in 2 parts, an upper and a lower section. The surface of the mold is perfectly smooth and has a mirror finish that guarantees an excellent luster. The graphics are laid on the mold before molding begins. This way they're well impregnated in the plastic. It's an operation that requires quite some dexterity because, contrary to self-adhering stickers, these graphics can't be lifted off if they haven't been well positioned. This is the yellow powder they're going to melt, linear polyethylene. It comes in several colors. The amount of powder to be melted is determined by the kayak model to be made. At the same time, in other molds, they're going to fabricate other parts of the kayak, such as the baggage compartment cover, the central support, and seats. The polyethylene is poured into the mold, which is then closed. All the other molds are closed as well. Before entering the oven, the molds are securely closed with clamps to avoid any loss of polyethylene. The kayak mold is put on a transporter and placed facing the oven. Because of the large dimensions of the craft, the oven has to be custom made. The whole kayak goes in. The oven is 7 meters long and has a diameter of 1.7 meters. The polyethylene melts at 288 degrees centigrade. To completely distribute the powder throughout the mold, it pivots on several axes. It turns on itself while the oven oscillates 30 degrees towards the front and rear. This procedure is termed rock and roll and lasts 19 minutes. Cooking is now over and the mold exits the oven, but the plastic has to cool in order to solidify. To do this, they place the mold in this cooling chamber. It must not be cooled too quickly or it deforms. A 4.8-meter kayak can lose up to 15 centimeters of its length. Now the cover of the mold is lifted off. Then they unmold the cover and the other small parts. The kayak is finally unmolded. Now they can proceed to machining it. While inspecting the kayak, they remove any plastic ridges left by the joint between the two halves of the mold. They now move to finishing. This begins with the screwing on of carrying handles. Here they cut the opening for the baggage compartment, and then they install the trimming. The central support is positioned. It plays an important role because it links the bottom and top portions of the craft. All that remains to be done now is to finish the baggage compartment. They attach fasteners, then put the cover in place and hold it down with a retaining strap. Finally, the kayak is packaged, ready for delivery. This company makes 12 kayak models of various dimensions. Drop a hammer or something heavy on the job, you may not be on the job the next day. But if you're wearing a pair of sturdy work boots, chances are you'll be just fine. Work boots are made from cowhide, which has undergone mineral tanning and finishing tanning. A waterproofing treatment completes the preparation. Let's follow the process. This machine is a shaver. It evens up the hide and opens its pores before it receives other appropriate treatments. They treat the hides in this retanning drum. Water, coloring products, and retanning products are at a temperature varying between 32 and 60 degrees centigrade. Hides are then removed from the retanning drum. The leather will then be vacuum dried for 2 minutes at a temperature of 70 degrees. Then the hide will be hung for 24 to 48 hours. Here the hide is stretched on a vacuum drying plate. It's evened out to get rid of any creases. A hide measures almost 2 square meters, and they'll need about 0.4 square meters of leather to make a boot. They begin cutting the boot parts. This punch, with the help of a press, cuts the different pieces of leather. They also cut brown fabric pieces, the interior lining of the boot, made from a foam base and woven polyester fibers. This paring machine thins the edges before they're sewn. During the cutting, each piece of leather is identified by its size. They now begin assembly of the boot. The two sides of the boot are sewn together on this machine. Now the front part of the boot is assembled. Excess leather is progressively cut away. The eyelets, made of steel, brass, or aluminum, are then positioned. Here they attach a foot mount on a form with tiny nails called tacks. The last is placed in the boot to facilitate the assembly of the front part. This carding machine removes any unevenness at the level of the lining before proceeding to the next step. They now install the tempered steel toe cap. The lining is pulled, they insert the cap and fix it well in place. The leather is folded beneath the boot, the bottom secured with a tack, and the sides fastened with hot glue on this seat inside lasting machine. The boot front is now finished. We get a good view of the application of the hot glue. At this stage, they removed the last, installed at the beginning. It's no longer needed. Now the sole will be installed. The heel core is of pine. It's put onto the sole, which will soon be secured into place. Here they proceed with machining and welding of the rubber sole to the boot tip. It's called vulcanization, done at a temperature of 165 degrees, and the sole is solidly installed. This machine sands the edges of the sole to eliminate any vulcanization residue. They also apply a sealant. They now place an insole inside the boot. Here they install the laces and stitch on the labels. The boots now leave for the packaging area. Building a pair of boots required no less than 123 different fabrication steps, including packaging. Each pair needs 101 meters of nylon, cotton, and polyester threads, and close to a square meter of thick and rugged leather. You know those big electronic signs with lights, color, animation? Well, this little thing is where it all starts. Digital electronic signboards are sometimes used as giant television screens or to post written messages. They come in different sizes, from a few meters all the way up to several hundreds of square meters. The creation of a sign starts with plans drawn by engineers and architects. Hundreds of plans are created by computer, among other methods, and require between 2 days or even a month of work. Millions of tiny lights, or light-emitting diodes called elements, make up the screen's surface. These elements are made of germanium, gallium nitrate, and silicon semiconductors covered with plastic. These elements have to be placed so as to form a matrix. Each of the 20 machines at this plant can install and solder 1,500 elements an hour. Lighting up an element requires only 10 to 20 milliamperes, and they last for about 150,000 hours. All the wires are placed behind the matrix and the different electrical connections. This conceals everything behind the sign and shelters it from the weather. Depending upon the distance from which the sign will be seen, spaces between the elements vary from 2.5 millimeters to several centimeters. A workman now makes the electrical connections. The wires have to be solidly connected to resist shaking caused by movement of the signboard. The matrices must operate together and require controllers which send information from one to the other. Thus, each group controls its own image. Each matrix has to be electrically powered and integrated to its own 5-volt element illuminating connector. Sometimes the matrices are made in 2 pieces, one supporting the elements and the other having the components. In this case, it simply requires 2 cards to establish the contact. Now they connect the information cable, which lights up and extinguishes the elements. Each matrix has 2 connectors, one which supplies the electric current and the other which carries the sign's information. Here they verify the functioning of each matrix. Then they can begin to join matrices together to construct the signboard. We see here all the colors assembled as they will be on the screen. The boards are sometimes installed outside and are thus vulnerable to the weather. That's why they put on this rubber strip which waterproofs it. The matrices are now assembled together. Then 10 matrices are joined to make up a module. At this stage, they insert the signboard conductor. Then the wires are connected. These wires transmit electric current and all the information relating to the sign. The elements require a very low voltage current, about 5 volts. Each module is then provided with its own converter to maintain a steady voltage. Then all the modules are assembled in the signboard support, and the many electrical connections linking the different modules are made. This gigantic signboard is a composition of 35 modules and 12 matrices. The signboard is almost finished. They now check the color, the luminosity, and the resolution of the screen. The signboard is made of 120,000 electrical light diodes and took nearly 3 months of work. Each year, this company constructs hundreds of digital signboards requiring about 100 million lighting elements. I've never been an early riser, but hey, I've got to eat. So I have a bowl for breakfast, a snack bar on the run. Thankfully, the goodness of cereal comes in many forms. Our breakfast cereals were born out of religious beliefs of the American Seventh-day Adventists, vegetarians, who in 1860 founded a sanatorium where patients were fed only cereals, wheat flakes invented by Dr. John Harvey Kellogg. His brother, William Keith, saw a promising future and built the first flakes factory to market the product, whose success would later be imitated by the famous Charles William Post as Post cereals. The making of frosted corn flakes starts in this cooker. The corn kernels are cooked here for 2 hours and 20 minutes. The corn kernels are then ground up. They're ground up by this endless worm screw. It also determines the number of kilos of kernels needed to make up a cereal recipe. The ground corn is next dried in a dryer unit, an important step before they're cooked. To give them their nice flat shape, the corn kernels are crushed in the flake roller. 2 rollers turn opposite to each other, and the kernels fall into the constricted space between them. The flakes then fall onto this conveyor, and the next step will be cooking. The flakes arrive at the cooking oven. They're shaken to make sure they will be uniformly browned. The flakes exit the oven well browned. Then they fall into this chute and head in the direction of the next step. This vibrating conveyor sorts the flakes and retains only the right-sized ones. This drum mixes the flakes and sprays them with a sweet solution boiling at 230 degrees centigrade. The sweet solution is dried, and a rake uniformly spreads out the frosted flakes on the canvas. Now they add in vitamins. The cereals are placed into this rotating drum. The vitamins are sprayed onto the flakes by a series of jets. The cereals are now finished, and they head toward the packaging site. This packager fills the bags with cereal. It handles between 40 and 45 bags a minute before they head off for final packaging. This plant doesn't only make cereals, it also makes soft cereal bars. This kneader mixes the ingredients, oat flakes, rice, and syrup. The preparation is mixed twice a minute. When well mixed, the preparation is poured into a large container. They will now proceed with the molding of the bars. The contents of the bin are emptied onto a conveyor, and then the preparation is spread out. Here they add chocolate chips to the preparation. The mix is compressed to the desired bar thickness by this roller. The bar separator then divides the mix into 35 equal strips. And then a guillotine cuts the bars to their proper length. The bars continue circulating. This equipment is used to line up the bars and make the packaging process easier. Side by side, the bars are here turned so that they run one behind the other. This roller applies a delicious caramel fondant to the bars. This caramel fondant then cools and sets. They're now at the final stage of production, coating with chocolate. About 180 kilos of chocolate are needed for the bar recipe. Now finished, the bars are ready for packaging. This machine individually bags the bars. Finally, they proceed with the packaging. These tasty bars will be enjoyed by children as well as adults. I hope you enjoyed our show today. We wanted to take you behind the scenes to the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.